The population of a certain bacteria triples every 6 hours. So we want to find a couple things here. We want to find the growth constant, K. Second, if the initial population of the bacteria is 3,000, we want to find the number of bacteria after 10 hours. And then lastly, we want to find how long will it take for the population to reach 30,000. So we know that we have the population growth model, right? A equals A naught e to the kt. Okay, remember, A naught is the initial population, and A is a population at time t. Right? Let's think about this. If the bacteria triples every 6 hours, right, then when t is equal to 6, okay, when t is equal to 6, right, A divided by A naught should equal 3, right? Think about that. Okay? For example, if A naught is 100, then 6 hours later, what should the population be? It should be 300, right? So whenever t is equal to 6 and we divide these guys, right, then that ratio should equal 3. Okay, so we can actually do that, right? A divided by A naught is equal to e to the kt power. And this is just equal to 3 when t is equal to 6, right? So 3 is equal to e to the 6 times k. Okay, now at this point, right, we can take the ln of both sides. So the ln of 3 is equal to the ln of e to the 6k. Okay, and then the ln of e just cancels out, so ln of 3 is equal to 6 times k, right? And now we can solve for k. K is just ln of 3 divided by 6, and when we calculate this number here, okay, we get a decimal. Okay, so I'm just going to round this to 6 decimal values. Okay, 0.183102. This is the growth constant. Okay, so we know that our model then, right? Our model is A equals A naught e to the 0.183102 times t. Okay. Now, if you look at the second question, it says if the initial population is 3,000, find the number of bacteria after 10 hours, right? So to answer the second question, okay, we need to find a population. If the initial population is 3,000, we want to find 0.183102 times t, but what does it say about the time, right? It says 10 hours later. So we're going to multiply this here by 10. Okay. Now, in order to remember to calculate this, right, just enter this in your calculator, do the e part first. Okay, so you have the e button with the exponent. Make sure you put the exponent here in parentheses, okay, and multiply that by 3,000. Okay, remember, do not clear it out, do not round anything. Okay, you should be able to enter these in one by one, okay, to get the final answer. Okay, so the final answer then here is what, 18,721. Okay, make sure you get that answer here. Okay, I did round this one here. Okay. And then the third question is what? How long will it take for the population to reach 30,000? Notice that we're going to solve for t here, right? But that means that A is a population at time t, right? So what does that mean? It means that 30,000 equals 3,000 times e to the k power. Once again, we know what k is, right? Times t. Notice we're solving for t here, though, right? Okay, we're going to solve for t. Well, what should we do then? Okay, first thing we should do is we should divide both sides by 3,000. Okay, so if we divide by 3,000 here, that's obviously going to cancel out on the right side. Okay, so we're left with e to the 0.183102 times t. Okay, but 30,000 divided by 3,000, okay, that's just equal to 10, right? So 10 is equal to e to the 0.183102 t power. Now once again, to solve this, we need to take the ln of both sides. Okay, so the ln of 10 is equal to the ln of e to this whole number again. Okay, but the good thing about that is ln of e just cancels out. So then ln of 10 equals 0.183102. Remember, that's the k value, right? That is our growth constant times t. And finally then, right, we should be able to solve for t. Again, ln of 10 divided by 0.183102. Okay, now, again, when you're doing these in your calculators, right, ln of 10, right, you should hit ln of 10, enter, and then divide 0.183102. Okay, you sort of don't want to do this all in one screen or in one shot here. Okay, so once you get this, you should get about 12. I'm going to round this once again to two decimal values here, right? 12.58 hours here. Okay, 12.58 hours. Okay, so based on the idea, right, that it triples every 6 hours, right? Think about it. It triples every 6 hours. So if the population, initial population is 3,000, right? Then 6 hours later, it should be 9,000, okay? And then a little bit after that, right? So after 10 hours, the population has reached 18,721, okay? And then it'll take us about approximately 12, and a little bit more than 12 and a half hours for this population to reach 30,000.